Okay, in this one we've got a shopkeeper who thinks that the average amount spent is 20. And we've got some data about what they do actually spend, and we've got to use a sign test to test this belief with a significance level of 10%. So because it's a sign test, I don't have to make any assumption about what kind of distribution the data comes from. Okay, but for step one, which is my hypotheses, I do need to make sure that I word it correctly. So the sign test, when I'm using it about an average, okay, the sign test works specifically with the median, because the probability of being above or below the median should both be a half. Okay, so H0 is that the median amount spent. So when I'm testing an average, then H0 is the specific claim for a particular value that it equals. So the median amount spent is £20, except we've got to be really careful. They want us to say the population median time. Okay, if you just say the population, the median, you might not get the mark. And then the alternative hypothesis can be one-tailed or two-tailed, so it's again going to be about the median amount. Okay, but this time I have to decide, do I need the median amount to be greater than or less than or just different from £20? Well, the belief we're testing is that the median is £20, so there isn't any need to contradict that. There isn't any need that it's bigger or less. It could just be different. So the median amount is not £20 is my alternative, and therefore this is a two-tailed alternative hypothesis, which I'll be needing to use later. And again, I should have population median. They may not give you the mark for just saying median by itself. You need to say population median. Okay, and I need to know the significance level is 10%. We'll come to that later. Right, so that was step one, the hypothesis. Step two is always the test statistic. Okay, and in the case of the sign test, that's just a binomial probability. So we need to set up a binomial distribution. So the number of customers who spend more than £20, that should twiddle a binomial distribution. Okay, so I need an n value and a p value. Well, p for the sign test is always 0.5. We're dealing with a median, so the probability of being more than median should be 0.5. And how many customers were there? Well, my sample has got 12 customers. So I should have a binomial situation where each of the 12 customers has a 0.5% chance of being above the median. Okay, and if the median is 12, then that will be the probability of being more than 20. So I now need to look at the sign of each of my differences. So if I'm above the median, okay, or the suggested median, 20, then I'm going to have a plus. If I'm below it, it's a minus. So 5.57 is a minus. 21.95, that's above £20, so that's a plus. So it's this one, that's a plus. This one's below. This one's below. This one's a plus, this one's a plus, this one's a plus, this one's a little bit below, this one's a lot above, this one's a little bit above, and this one's above. So I've got, out of my 12 customers, I've got 1, 2, 3, 4, 5, 6, 7, 8 customers who are above the median. So the probability I need to look at, now it's not the probability of equaling 8, okay, it's the entire tail that I'm within. Okay, so the probability that x is greater than or equal to 8. So it's a binomial distribution with possible outcomes from 0, 7, 8, 9, up to the maximum would be 12. And I want to be 8 or more. So I want these values, I don't want these values. So I want to work out the size of this tail probability, all of those values combined. So that's a probability I'd like, but my calculator only works from the bottom upwards. So my calculator will tell me the probability of being less than or equal to 7. And that's the one that I need to take away from 1 to get the actual probability I want. So my p-value is going to be 1 minus, and now I need my calculator. Is my calculator, so I need to go into mode 7, and then I want second screen binomial CD, which is option 1. Variable is fine, so I want to be, well, I'm going to look at the probability being 7 or less, so 7 or fewer, Okay, and my n is 12 and my p is 0.5. So that's the probability my calculator gives me, 0.806, and I need to take that away from 1. So 1 minus 0.8061 is 0.1939. Okay, and that's the probability of being in this tail here. Okay, so I can quote that as my test statistic, but then for my next bit, my critical value, all I need to do is compare this, or compare with the significance level of 10%. So I'm going to be making a comparison of 10%, but because this is two-tailed, what I've done here is worked out the probability size of the tail that this 8 happens to lie in. This 8 is more than half, so I'm in the top tail. But I need to allow, because it's two-tailed, for the bottom tail as well. So I need to compare not this probability, but twice that probability. So I need to look at 2 times 0.1939, and that equals 0.3878. Okay, and that I need to compare with, well, my critical value, my significance level, is a 10% one, so that's 0.1. So the comparison I need to do is 0.3878. Okay, and I need to compare that with 0.1, and it's greater. Now 0.1 is the low probability, so to beat that, I would have to actually be less than 0.1. So this 0.3878 is quite a lot bigger than that, so it's not significant, okay? In order to be significant, I'd need to be in a really quite small tail. What this is telling me is the tail I'm in is by itself quite large, and I need, because it's a two-tailed test, double this value is even larger, and it doesn't beat this 0.1 significance level that I've got to beat. So it's not significant at the 10% level. So of course that means it's not significant, so I'm going to be accepting H0. And in context, when I accept H0, I always say that there is no evidence. So there is no evidence at the 10% level that, well, what were we testing? We were testing whether the median amount spent was £20 or not. We found no evidence that that's wrong. So there is no evidence at the 10% level that the median is not £20. So the shopkeeper thought it was £20. Our conclusion is, yes, it seems that it could well be £20. We didn't have any evidence to overturn that claim, so we have to accept what he says. We certainly haven't proved he's right. We never can prove that the null hypothesis is correct, but we accept it because we haven't got the evidence to reject it. Now, we could ask, is this in context enough? Maybe not. So we should, as well as saying that we've got no evidence the median is not £20, we can say we accept the shopkeeper's, was it a claim or was it a belief? It was a belief. So if there's a belief being described, then it's always good to refer to that in the conclusion.